Let me get started. Welcome. We are so glad you're here. Welcome to the first meeting of the decade of the R user group here in Salt Lake City. We are so glad that you are here. Today is our Community Lightning Talks meeting. So we're going to be getting through, we believe we have 6 speakers who are going to be sharing talks between 5 and 7 minutes. So I am going to time them and try to keep them keep it so we can get through these in time to have us all leave when we need to get where we're going next. I'm really excited about this because last year it was really interesting to hear from a variety of people on a variety of topics. So let's see, what other announcements do we have before we're going to hear from our host. So we, you can keep track. Probably most of you found us through our Meetup site, but you can find us there. We'll know about what's going on at our various events. We meet about monthly. We have been, probably most of you know, we have been meeting at lunchtime. We're interested in whether that is the best time for our community. So if you have strong feelings on lunchtime versus an evening meeting, let us know. I know this is a biased sample because you're all here at lunchtime. You managed to make it, but we are, interested in that kind of.
And if you have a space that's available in the evenings, let us know, please.
Yes. Yes. If you have meeting space that would be available in the evening, we would love to know about that. There are stickers for our group that are right here if you would like to come and grab a sticker. And if you're interested in sharing something with us, we are looking for some speakers for the spring semester. So we would love to hear if there's a package that you have recently learned how to use, or a project in your at work or in your research that you'd like to share. We would love to hear from our community about what's going on. I didn't introduce myself. My name is Julia. I'm one of the organizers. Our other organizers are Mark and Andrew up here, so we're really glad you're here. Our host today is going to share a little bit about what they do here. I guess, so we can record it, I guess.
Okay. Hi, guys. My name's Adriana. Thank you all for being here and taking your lunch hour to come down here. Really quickly, I'm just going to take a few minutes to talk about our enterprise projects. It's something that's really unique to Newmont, where companies can recruit students during their senior year here, the last 3 quarters, and they can come to their companies 20 hours per week to work on tech projects. And this really benefits the students so that they can build their portfolios and also just get real life industry experience before they graduate. And it's also great for the companies to kind of test out the talent before they hire. So that's something that Newmont's been doing since day one, 13 years ago. And we have now done, I think to date, 680 enterprise projects with 160 unique companies. So if that's something your company or organization is interested in learning more about or participating in, I have some brochures that I will leave here that have more information overall for the enterprise project. And then I'm also leaving our Director of Corporate Relations. She's over the enterprise projects. I'm leaving her contact info here. So if you guys are interested, feel free to grab that on your way out. Otherwise, if you have questions, I can try and help. That's not really my area. I'm just stepping in for her today. Otherwise, thank you for being here. And you guys, I think the next class doesn't start till 1:30. So if you go a little over, that's okay too. Awesome. Thanks, guys.
Thank you. Awesome. Thank you so much. All right. Levi, I know you stepped in a little late. Are you okay to go first? Okay. Do you want to come and get set up? All right. So there's that and that. Okay. So we've got, I believe, 6 talks. They really range topic, which I think is fantastic to get a little bit of everything. And I'll try to set the camera so we can get through it before we're ready to go. And I'm really excited that Levi is here because I've heard some really interesting perspectives from Levi over knowing each other, and so I'm interested to hear about how website uses R for knowledge sharing. So thank you.
Thanks, Julia. Does this work at all?
Yeah.
Perfect. Okay. Awesome. Well, thanks for that intro, and thanks for the organizers. You guys are amazing. Thanks for doing this every month. It's really a great community resource. Just in terms of a random question, does anybody use a water pick regularly? Water pick users? Yeah? Isn't it delightful? My dentist got me on one of these about a month ago. Can't stop talking about it. Okay, so I'm at Pluralsight. I'm a data scientist over there. I was at Health Catalyst for a few years, helped build the data science function over there. So let's just step back a little bit, talk about how data science works at Pluralsight, and then we'll get into some of the knowledge sharing stuff. So I'm in the experience org, the product org, and there's about 15, maybe 20 machine learning engineers and data scientists in that org. There's also data scientists elsewhere that work with finance and sales and marketing. We let you be flexible across R and Python. If you're using Julia, haven't helped you. I'm intrigued by it, but we haven't played with it yet. So we're mostly focused on AWS. We also have some people tinkering around with GCP. So there's some teams that are actually using it in production, I would say. And then embedded data scientists and MLEs. Welcome, guys. Thanks for coming out. So we used to be sort of farmed out from a central team, but data scientists now work with the product team. So these product teams have dedicated designer, product manager, engineers, and some have a data scientist and or MLE. So the data sources range from clickstream. So since a lot of our traffic is live from the web, we have a ton of Adobe Analytics data that we play with. So that's a major source. Then we also have product databases where the actual engineers are recording things in the databases, as you might imagine. And we play with that in several different ways. So we have those tools there. So in terms of how we're laying on top of that, where it might get more interesting is we use a lot of internal packages, both across R and Python. And these are often around just connecting to things, making that streamlined. So ODBC delivery, so making it really easy to connect to Impala and to Hive and to Postgres and making it so it's not easy to check your credentials into GitHub. And for those of you who are into the R package world, it's been amazing seeing what RStudio has been doing lately in terms of providing a coherent experience across notebooks and apps with Shiny and IDEs with RStudio. And half of our data science function is really behind a lot of that. The other folks are Python folks, but we love the coherent environment that RStudio is providing. We're trying to take advantage as much as possible. And so in these packages that we have for R, we not only have easy database connections and Hive connections, but we have sort of this burgeoning idea of these R Markdown templates. I don't know if you've played with them much. Anybody gotten into templating for R Markdown? Okay, a few of you. It's pretty great. So the idea is that as you create a new R Markdown file, you have this option. So the seeker is our internal R package, and you can essentially create as many as you want and load them via just loading the package itself. And the idea is that you have something like this that results. So what we've done is we've sort of prettied it up a little bit. We've gotten some CSS that incorporates into our Markdown, come up with kind of a template. The idea at Pluralsight, in terms of data scientists, we don't inscribe things in stone. We're not wagging our fingers and saying you should do this or that, but we try to provide great tools that make it compelling for people to make their life easier and thus kind of follow the standard just because it's so much easier than the alternative. This is kind of one of those things that helps with that. And this also helps with the analyst set. So we have maybe 10 product analysts that are mostly in the Adobe world, Excel. We're trying to help them skill up and get into R and Python. And this is one of the ways to do that. Found R and R Markdown fantastic ways of getting people actually leveling up from the Excel world. And then the knowledge repo. So we wanted something for sharing these notebooks and sharing our work that had dynamic rendering, meaning you can interact with it live. We wanted something that you could organize by tags and easy publishing. So it's easy to throw something up on a server, but it's harder to get some of these nicer functionalities. So this is something we're looking at to share our work. And we wanted Python support as well, which is not necessarily easy to integrate those two all the time. But what we ended up getting was RStudio Connect. We're just barely starting up with this. So what RStudio Connect is it's basically a way to share your data science work across notebooks, across apps. So it's easily organizable by tags. You can see, okay, well, what's visible to me? What do I own? And then the interesting part is here, where when you publish something, you can essentially go and say, okay, which groups do I want to be able to access this? I want it to refresh on a certain schedule. I want to integrate environmental variables through this method here. And it actually pulls across your environment. So when you're working locally, it will sort of assess what all the packages are that you've used in this notebook and then create that environment in RStudio itself, in the server, so you can share it all out the exact same way that you built it locally. I believe that's it. Oh, just some final principles. We'll leave those up there. I think we're about out of time. But again, source control reproducibility. We're not wagging our fingers, but rather providing a great happy path, a great tooling, so folks just sort of follow that direction naturally, and standards emerge on their own. But thanks all.
So next we're going to have, so Sean Hinder is going to while we're switching and getting the mic up, we'll probably have time for like one question. If you have a question about the workflows at Pluralsight or how that's used.
Yeah. Balancing the your R pipelines, right? Are you using RStudio Connect to publish the work done by the?
Yeah, there's some wrinkles, but they do have some tie-ins. There's a nice tax too that makes it possible.
Thank you.
So you can do different notebooks within RStudio Connect.
Okay.
Yeah, that's a great question.
Has that been successful somewhat?
We've been testing primarily with R thus far,
Okay.
but the functionality will come with pretty confident.
Okay. Cool.
Okay.
Great. So next we're going to have Sean speak about spreadsheets and how to automate them.
Okay. So thanks, guys. So I've been to a few of these meetings, not a ton, but I'm really grateful to present today. Mark Nielsen, I think, is one of the organizers for these meetups, and I actually work on his team at Intermountain Healthcare. So I'm going to talk about a project that I've been working on working with Excel. For me, I don't really use Excel very much, okay? But I work with a ton of people that do use Excel, and I don't think Excel is going to go it's going to go away anytime soon. So I need to figure out a way that I can still use my current workflow, but also be able to help the people I work with help their workflow as well. So the one experience that I had recently with this was we work with a team that's called Care Management, and they work with trying to find patients that they can hopefully give some additional help to. And so we have a model that I'll explain a little bit that kind of flows into that. But as part of that, we need to create, at least for a pilot that we're doing, we'll probably do something more robust hopefully in the future. But for the pilot, we needed to give 11 care managers a personalized Excel workbook every week. And if I had to do that manually, I would not enjoy it. It would have been really difficult. So luckily, I found this package in R that actually automates this. So I work with the SQL database, but then I can pull everything into R, manipulate it, create some really nice spreadsheets, and then send it to them every week. So I'm going to talk a little bit about how this package works and what I learned from it. So this is kind of the workflow I had. So we have an enterprise data warehouse where we store all our data. We look for some recent life events, and this is part of our model. And then we needed to be able to create these formatted patient lists that they could edit, and then that we could also get feedback from them. And so once they edit their workbook, because it's hosted on OneDrive, we can access that and pull the data with the same package. So I'm using OpenXLS to create these lists and also to read in the data once they put it in. And it actually works pretty well. So let me just show you a little bit some of the functionality of this. And there's actually a lot, and so in 5 to 7 minutes, I can't really cover all of this. But I can highlight some of the things you can do. But basically, there's things in Excel that I don't know how to do in Excel that you can do in this package. So it's pretty expansive. So like for example, I think I learned this once. You can create named regions in Excel, and a lot of people do that. You can do that with this package. Data validation, making sure that they put the right input in. I actually use this for the package, or for the workbook I created, because they had to give feedback, and it needed to be just a couple of options, right? So I didn't want any free text in there. So I actually use that. All of the formatting, anything you can think of, you can do as well. So let me just show some quick summaries of how this works. So you'll load the package, and you can actually create the workbook. And one thing I really like about this package is you can actually open it up interactively. And this will open a spreadsheet that's not saved. It's just a temporary. So you can kind of see where you're at and visualize that. And then just close it and then keep working. And then it really helps you think about the process of creating the workbook. So I don't actually have the actual workbook because it has private health information, but I have the IRIS data set, which is a very important data set, as we all know. And so with this, you can actually you can write tables. And one thing I really like about this is you can save formats. So I have what's called title style here. And this will allow you to apply the same format to multiple spots in the workbook, which was really nice and useful for me as I was creating different sheets on this workbook. Another thing too is that these tables pop up a lot, right? So I haven't seen a package until this that can actually create these tables where you can have the filters and all that functionality in Excel. So that was actually pretty nice too. It's this write data table function. And then you can also format it, as you could see here before. The widths weren't very good, but there's ways to format the tables and so many different options you can do with that. And then another thing that I thought was really cool is I love the plots that I put into R. I know how to do that. In Excel, I am lost. I don't know how to do all that stuff. So one thing that's really nice here is that you can actually create nicely formatted images in R, and you can put them into Excel. You just have to specify what sheet cell you want to put it into. And then voila, you have an image there that you can see. And so I think that's pretty much all I have there for that. So just kind of a short and sweet introduction to this package. I have some code here on GitHub that I posted if you guys want to look at it more, just to kind of see how it works and some of the stuff that I did. But yeah, that's all I have, so thank you.
Okay. Here. Yeah. Enter. Okay.
So I have it. I know, so one thing about this package is, I know there was another package, oh, I'm sorry, I need to do my research a little better, but I think there was another package that was reliant on some underlying language.
It was, yeah.
Excel Connect.
Excel Connect used Java.
Java, yep. This one doesn't use Java, thank you. So I found that this one worked pretty well.
Worked.
All right.
Thank you so much, Sean. All right, so next, Cindy is going to be speaking about differential item functioning, which was interesting. When you sent me your slides, I was like, oh, I'm glad to hear about this because it's not something I'm as familiar with. So thank you.
Yeah, thank you. Is this working?
Yep.
Okay, cool. It's a pleasure speaking to you all today, and my name is Cindy Weng. I am a data analyst, work at Western Governors University for the psychometry team, and I actually don't know much of you except Andrew from University of Utah, but yeah. And what I would like to share with you is a psychometric analysis, which is differential item functioning analysis. And the data story is to convert our code to Databricks notebook. I just want to get a feeling, is anybody have used Databricks in this group? Anybody? No? Okay. Right, so my data story today is to convert our code into Databricks notebook and to deliver analytics job much more effective and efficient by performing SQL query and data analysis at one platform using Databricks. And differential item functioning analysis is an important part of test validation for a large scale of tests, especially in the psychometric society. And diff item meaning that the item is in favor of the group that may lead to a biased result. And there are two kinds of diff items, uniform versus non-uniform diff. And this is item characteristic curve. And the figure on the right is uniform diff item. This implies that the item, the question is equally the same between two groups. And the figure on the left is non-uniform diff item, which means the difference between the groups is not constant. The data contain 57 items, true and false questions, and the total unique attempts are 284. We had 49 females versus 235 males attempts. And the method to detect uniform diff item is generalized mental handle using diff GMH. And to detect either uniform or non-uniform diff items is likelihood ratio test using diff logistic. And here is the first 9 command cell. And the first command cell is to switch to R code from SQL, which is using %R, and then load diff and SPAR packages. And the second command line is data preparation. What I did was to convert SPAR data frame into our data frame. And then we are ready to conduct diff. So here is a line of our code and using diff GMH. And the focal name is where we define which group is much more less likely to perform well. And the purified true is a way that finding the diff items conditioning on non-diff items. And here's a plot, mental handle statistic plot. We identify question number 6, 39, 38, and 44. They are uniform diff items. And the next step is to call likelihood ratio test diff statistics using diff logistic. Here's we added this criteria assigned to LRT, and LRT stands for likelihood ratio test. And here's the LRT statistic plot. The question item number 6, 39, 42, and 44 are either uniform or non-uniform diff items. And then the next final step is to figure out which item is uniform and which item is non-uniform diff. And based on these figures, item number 6 is non-uniform because there's an interaction between groups. And question number 44 is uniform div item. And this is my presentation, and thanks for your attention. Thank you.
Thank you so much, Cindy. That was really interesting to have that introduction to that. So let me remind myself who's coming next. Daniel is coming next. So while Daniel comes up, actually, Cindy, do you want to see if anybody has a question while Daniel gets set up? So does anybody have a question? All right.
Is this work you're doing with the whole team, or is this something you're mainly doing yourself?
This is for our team, and the goal of the project was to be able to load it in Confluence.
Oh, very cool. Nice job. Thank you.
Nice. Thank you so much, Cindy.
Great job.
All right, so next we have Daniel, who is here from the Sorensen Impact Center. And so Daniel is going to be talking about something which is interesting, like an agent-based modeling, like simulations, which is something I think we don't talk about enough in our sort of like machine learning, statistics-oriented mind frame. So I'm very happy that you're here sharing this talk with us. So
Thank you.
Daniel.
Thanks, Julia. And thanks, everyone. It's always a great pleasure to get together with a bunch of R enthusiasts. So my team and I work at the Sorensen Impact Center. As Julia was saying, raise your hand, guys. We are policy wonks who use data science to try to help governments, nonprofits, foundations figure out big, thorny questions. So it's fun work. And before I dive into it, though, I'm going to start with a quick mind teaser. So family has 2 children, one of whom is a boy. And we'll make a simplifying assumption that genders are equal, boy, girl, 50-50. So what's the chance the other child is also a boy? And I'm going to pause on that and describe the kind of 3 whys. And most of my talk is about the why simulate. At the end, I'll point you to a couple resources on the how. I think it's probably too big to cover in 7 minutes. So for me, the reasons are, 1, to clarify the situation. So usually you're not sure exactly what the client wants, right? And you're trying to kind of clarify even their thinking. Like, what do you think is going to be the outcome of this new policy measure? And so getting them to sort of think through with you so that you can simulate. So the second one I skipped to is simplify the complex, right? Policy is in a complex and maddeningly difficult and frustratingly complicated world. So you want to try to boil that down to some easy functions and then loop that around. And I'll kind of show this with examples. And then the third is explore what ifs. And I was saying this to my friend the other day, who's a mathematician, saying, I always found math very frustrating, where you're trying to get to an answer and you can do everything seemingly right and come up with the wrong answer. And I think I love simulations because a lot of times you come up with like 10,000 answers and they're mostly right, but you're probably off. But you're able to explore this like space of possibilities in a way that I think is really unique. So back to our puzzle. Did anyone have this as their answer? 33%. All right. So you probably heard this. This is kind of a canonical puzzle, but it's also a paradox. And on the face of it, this is probably the easiest way. If you just take out all the pairs of girl, girl, then you can come up with that answer of 33%. But put another way, a family has 2 children and you are introduced randomly to their son. So now what's the chance the other child is also a boy? And this changes things. And instead of 33%, now you arrive at this 50%. And I know this is probably, head-scratchingly weird. I know when I first heard it, I was like, how can that be? So whenever I get to those kinds of situations, I run to a simulation because I'm like, I want to prove this somehow. And again, this is like, once I go in there and start thinking about, well, what does it mean to be randomly introduced to a son? So you start kind of defining all the probabilities that you're hitting along the way and really like clarifying the situation, right? Now it's not just you just happen to know that one child's a girl. Now it's specifically you've met the child, but specifically it was random. It wasn't like this is my first child. It was randomly you meet the one. So this is a simulation I did of it, and again, like I've done dozens of simulations just to prove weird things to myself, and I think it's a fun way to kind of learn how to do it. So that's one. The second, simplifying the complex. Here's a project we worked on for the state government. They came to us and said, we want to reduce recidivism. And so this is the rate at which people return to jail. And what I found pretty quickly in trying to clarify thinking is recidivism is measured all kinds of different ways. But the canonical way is the number of people, the percent of people who return to prison after X number of years, usually 5. And the number is really high. 55% across the country will return to prison after 5 years, or within 5 years. So that's really mind-blowing. And of course, it translates to big cost to society. But the question is, how big? What does that mean that 55% will return in terms of like dollar figures? Because there's obvious incentives to stop people from returning. Help them, of course, and then secondarily, help criminal justice budgets. So this was their question, and that's a tough question. How do you turn that into a dollar figure, the number of people who will return within 5 years? Because what you want to know is something more concrete. It's like, well, how long will this group spend in prison over the next 5 years? And that's a different question, and one that there aren't good statistics on, I discovered. So what we set out to do is essentially simulate these returns. And with national data and some local data, we could get a group of, I did 10,000, but here just to demonstrate, here's 100 people. And this is called kind of the freedom axis. So the x-axis is the months free. And then the green would be folks that are free. And then as they go back into prison, we would say that they're in prison for the average sentence, which again, tough to kind of work out analytically. But through simulation, we could figure out how long, how much time total will a group of people spend in prison over 5 years. And this helps us get at an underlying cost to society, which is very big. Yeah, I think you could work this out analytically. I think you could probably come up with some kind of Markov chain or something. And people have suggested different kinds of models that might work. But I found this simulation method to be just so much more straightforward, at least for me to get and code in. I see a question. I'll fly through the slides and we can do that at the end. So finally, the explore what ifs. And this, I said, is why I love coming up with 10,000 answers rather than one, because usually in policy, you can't tell somebody, oh yes, this many people will return, right? You're saying what we wanted to say was something like a range, like, well, it could be 100 people or it could be up to 300. Probabilistically, you're looking at 250 or something. So this was some work we did for the Gates Foundation, still kind of underway, and we're improving it as we go. But we did simulations in R on the outcomes of every single college and degree-granting institution in the United States. And their question was, there's going to be this huge dip in students. What will that mean? And so what we gave them is, I think what they really needed was sort of a range. Like, here's a pessimistic scenario. This is the next 10 years. And this is the number of students that we might expect in the post-secondary college system. So you could expect a big drop in students. Most likely you'll expect a drop, maybe not a huge one. And then in an optimistic scenario, it kind of goes up and levels off to where it was in 2017. So just that ability to tell the Gates Foundation and show through some data and modeling what this might look like through these kind of different what ifs. And then we could say, if this happens, then this, right? It's a different answer than I think you get through more traditional methods, we'll say. And then these are just some great graphs we came up with on different racial breakdowns of students, because once we had the data, we could crunch it up all kinds of different ways. So those, again, my 3 reasons for simulating. Thank you so much. Happy to take any questions. And just to point you in the direction of like the how-to, I thought this was a really terrific post by David Robinson about tidy simulation in R. The principles are usually the same. You're usually kind of iterating over you set up one case and then you iterate it thousands of times. That's a kind of standard practice. So here's a how-to, and thanks again for your attention.
Thank you so much. So as you get that off, and then Peilin Chen.
Yeah.
Awesome. So come on up, get the mic, and then ask your question, Peilin.
Okay. Thank you for your wonderful talk. I'm just curious about like, you say you do simulation about the return to the prison, right? Did you use any like distribution assumption?
Yes.
Like,
Yeah,
did you validate that assumption or?
Yes, thank you for asking that. Yes, we did. We used assumptions about the distribution of prison sentences. So we had kind of an average, and then I knew a little bit about like the median mode and mean and kind of the spread. So I made some assumptions. I can't remember which distribution I used, but I had some theoretical justification for it. And then I had pretty good data on the returns, which I used to. But yeah, usually. Thanks for that question, because usually these involve assumptions. You have to be very clear about what you're assuming here.
Yeah, thank you so much.
Nice. Thank you so much,
thank
Daniel.
you.
That was super interesting. And so next we have Peilin.
Yeah.
So
can anybody hear me?
yeah, so it's actually mostly for the recording.
Oh, okay.
Yeah.
Okay.
Because we don't have speakers, it's so that's actually just for the speaking and recording.
Okay.
Does that make sense?
Okay.
Yeah. All right. So Peilin is going to be speaking in our next talk. So you can just
Okay.
arrow right here. All right.
Okay, thank you everybody. This is my first time giving a talk in our meetup group, and I saw a lot of people from my group. I'm from Intermountain. Okay, Mark Xiang, and hi everybody. So, I mean, the previous talks are pretty interesting, and I hope you find this interesting as well. But if not, it's okay. So I'm going to talk about a package called FDA PACE. It's a package for functional data analysis. So the reason I was looking for this package is actually last year I was looking for a job for a pharmaceutical company, and they asked me, what if you have, patients counts for white blood cell, but you don't have anything else? How would you measure what would contribute to the blood cell variation, and how can you predict the white blood cell would varies in the future? How can you give a trajectory? Then I was searching and for packages, and then this one come out. So I'm not going to use a blood cell count because that's their data. I'm going to use available data, okay? So first, what is functional data? So if we look at an example, it's about the Mediterranean flies, and we record how many eggs they lay on each day for 25 days. So here we have their ID. Okay, this just shows 100 of these flies. From this, it's like an art of some abstract modern arts, right? And I don't know what it is, but you can see it has high frequency measurement. And actually, you think about the process of laying eggs, it's continuous in time, but we only observe it at discrete time, right? So actually, it's a continuous functional data instead of discrete time data. Also, you have repeated observations, and it's very noisy and very dense. Okay, so it's similar. Another example of functional data is like handwriting. When you do handwriting on your laptop, it's actually a movement. It's changing with time. Although it's only recorded like discrete, but actually it's continuous, right? So these are functional data. And for that, Mediterranean flies, suppose this Mediterranean fly actually, triggers, it can destroy fruit. And you want to know like how they reproduce themselves, and you want to know how their reproductivities change, and possibly maybe we can find a subgroup that has a gene that has a low productivity, so that we can replace the flies with that gene, and then we can control them, right? So suppose you only have the number of eggs they laid. How are we going to do the analysis? So using that package, actually, you can estimate the mean productivity using the function. For functional data, we only observe discrete times, but we will try to smooth the discrete data using smooth method like Fourier function or bspline function. That's the usually way. So in this package, you can select the bandwidth and using generalized cross-validation to estimate the average of eggs laid every day across the 25 days. Also, you can have the confidence interval by the one you specify. And also, if we look at each individual, we say that we only observe the discrete data point. But we can find a smooth method to try to project the trajectory. So for example, the 3rd fly and the 10th fly, they have the number of eggs laid, right? And this is a trajectory predicted by the package. Of course, there are some errors, but you can always try to tweak the parameters or something else to make it have a better fit. So another way you can do is you can choose a clustering of groups. So as we said, this flies can destroy the fruit, right? We hope to find a subgroup that has a low productivity. And these are the general trajectories of how they produce eggs. And luckily, there is a subgroup that has very low reproductivity. If we can identify this group, then we can study them, and maybe we can have some improvement. Okay, so I think that's my talk. Any questions?
Thank you. That was very interesting to hear about that thing I was not familiar with. So if you want to stay and see if there's a quick question or two, we have Sean come up for our final talk to get this on. Does anybody have a quick question for Peilin while I get this switch?
Yeah, so I think the difference between functional data and non-trivial data is you can think it as a non-trivial data, but when you use the traditional trivial method, you always assume finite dimension, right? But for functional, it's like for every sample, you state it as a function. Whatever is a function is infinite dimension. It's like you're trying to approach any function can be approached, by simple functions. I'm not a real dimensional.
Okay, thank you.
Oh, okay, great. Thank you very much for that. Thank you. Great, thank you just in general for that, Peilin. All right, and so we made it to our final talk of the lightning talks. Everyone has done so good at keeping their talks on time. And I'm very excited about this because this is a package that I know and love, and so I'm excited that any of you who do not already know and love it will be exposed to it now and get to learn a little bit about it. So Sean is here and is going to talk about the naniar.
Yeah, is that how you pronounce it? I actually don't even know.
Australian, so
Naniar.
knows?
I
Who even
don't
knows
know.
how to say it?
Or what it means.
Yeah.
Yeah.
I forgot. I meant to bring you. I have a sticker for it. It has
Oh, shoot. The little hex sticker?
It has a hex sticker. It has the like from Narnia. It has the light, the
little lamppost thing?
lamppost.
Oh,
It has
nice.
the lamppost from like Narnia.
Is that the connection to Narnia? I never even knew that.
Yeah.
Oh, okay. That makes sense.
N-A-N.
Right.
Like
it's like an anagram of
Narnia,
yeah.
and the hex sticker is the lamppost from
Okay.
Narnia.
Okay. All right. Thank you. Well, it's great to be with you. I've been doing a data research project for some number of years now, and actually just recently stumbled across this package. As you know, data comes to us with missing values all the time, and this data had a lot of missing values, and it's hard to figure out what to do with missing data. And so the naniar package is really just kind of an introduction to figuring out what to do with missing data, and I'm just going to scratch the surface of some of the cool visualization tools that it has and talk a little bit about that. So, let's see, got to click there. There we go. So I've read in the data, and we have 5,000 observations on 9 variables. And these are the variables that we have. So gender makes sense. These 4 are survey questions that are given to patients that describe their motivation and satisfaction and effort going into treatment programs. The OQ is a standardized, validated, kind of gold standard test that's given. It's a test of dysfunction, and they give that at admit and at discharge to see if the treatment program has helped. Facility type is one of 2 options. We study outdoor behavioral health, so OBH, wilderness therapy programs, and also residential treatment centers. So you'll see OBH and RTC are the 2 faculty types, and we get their age when they're admitted. This particular study is about young adults. So I'm just going to go through a bunch of graphs that the naniar package will give you to kind of help you explore the missing data. To be clear, patterns of missingness can be sort of visualized here, but when you have missing data, there's really no substitute for domain knowledge. You should really try to understand why data is missing, and there's all this like whole literature about data missing at random, missing completely at random, missing not at random. There's a whole literature about whether you should impute data or just use complete cases, or there's all sorts of stuff. This is really none of that. This is just about visualizing patterns of missingness. So here in this particular graph, we have the 9 variables across the 5,000 observations, and the black lines are missing data. So I can see, oh, for example, satisfaction and effort are like half missing. These are post questions after they are done with treatment, so it makes sense that they're missing. A lot of questions that are at the beginning of treatment are there, and then they're missing at the end of treatment. And also that they seem to correspond to roughly the same cases in our data, right? When one's missing, the other one's missing, which sort of makes a lot of sense. Age at admit kind of scrolls off the screen, but then none of those are missing. We have all the data for ages, for example, okay? You can look at variables individually and just look at the numbers, right? So effort and satisfaction, again, are the most missing, and then going down to age at admit where there's no missing data at all. You can break it down by faceting. So for example, we have our outdoor behavioral health, we have our residential treatment. I'm really interested to know if one modality is going to generate more missing data than the other one. And what I can sort of see here is that not so much. It looks like the patterns of missingness are pretty similar across both of those types, right? I mean, we could drill down even further in lots of different ways, but that's actually a good start. Of course, sometimes the facility type is missing, and so we can also see when the facility is missing, are we also missing some of this data? And we're not missing very much, so that's good to know. If I were to delete those cases, I probably wouldn't be too worried about that, right? Here's another way of viewing kind of the same thing. Again, it's faceted. Not really faceted in this case, but it's broken down by OBH and RTC. And then we have kind of a heat map sort of thing going on here, right? Where we can see that age at admit is almost complete, whereas satisfaction, some of these are missing, and sort of the more yellow-green it is, the more missing, the higher the percentage of missing. This is nice because it's a percentage. The other one is like a number. So if my 2 groups were very different sizes, this would be the graph that I'd want to look at, right? Because it's by proportion in each group. So I can kind of see if there's lots of differences in the proportions. This is sort of by case. So I can just sort of tally up how many cases are missing how many variables. At the top, we can see that we have a significant, not very significant number of cases that are missing 7 of the 9 variables, right? Like almost all the data is missing. And then a bunch are missing 6, 5, 4. And then, of course, we have some complete cases, which are about the last, 1,500 or so, right? So if I were to do a complete case analysis where I just dropped anything, any row that had a missing value anywhere, I would be eliminating all of this data, and that's what I would sort of end up with is those 1,000, which regrettably in this case, it's probably the analysis we have to do, even though it cuts down my sample size a lot. Again, you can just facet this by whatever variable you want. And at least in this case, again, I can see that patterns of missingness are pretty much the same between the 2 facility types that we have, right? You can do cool things with like scatter plots. So for example, I might be interested in comparing discharge scores versus admit scores. And this is the data where I have those 2 variables. The red dots are where I'm missing one of the variables, right? So along here, I may have discharge scores, but I don't have admit scores. And then here I have admit scores and not discharge scores. And then I have a number of cases where I'm missing both admit and discharge scores, right? So you can kind of see, now here I don't see any interesting patterns, but you could detect possibly that there was kind of some clustering or something here, right? And you would say, oh, people who had higher admit scores are more likely to not have discharge scores, and then that would tell you something, right? You get some information out of that. Not so interesting in this case. And then once again, just the faceting procedure by which I can see if there's a significant kind of difference visually between the 2 facility types. So this is my favorite one. This is like the best graph of all. This is called an upset plot. And I love this because when you're looking at multivariate data, it's always so hard to know how to view more than 2 variables at a time, right? What's cool about this plot, how it works, is that here I have kind of the top 5 missing variables, right? And you can expand this to more if you want. This is just sort of the default. And what we have here is the combinations of missingness. So for example, the most frequent pattern of missingness are patients who are missing OQ, discharge, satisfaction, and effort. So these little dots here show the intersection of the variables that are missing those 3. And I have 1,500 patients that are missing that combination, right? And then I have a significant number, almost 1,000, that are missing all 5 of these, right? So does that kind of make sense how this works? Each pattern of dots represents a different combination of missing variables within each of those cases. And we just tally up those cases to understand which variables are going to be the most problematic. Unfortunately, the researcher I'm working with who's doing this analysis really wants to know about satisfaction and effort. So that's why we have to mostly just drop these cases, right? OK, that's all. Thank you.
Awesome. So does anybody have we can do like a question like we did for everybody else?
Yes.
Yes. So it seems like really like extensions for the. Do you know the package for the Data Explorer?
I don't know that package, no.
So yeah, it's kind of like it's kind of for the same thing with like the extensions with like the missing data stuff like that. So
Yeah.
it's pretty interesting to just like to make a fast set for the missing values.
Yeah, and there's lots of ways to slice and dice it, of course.
Right.
Yep.
Nice. Awesome.
Thank you.
Awesome. Thank you so much, Sean. And thank you. Let's one more time thank our speakers. I would like to congratulate them on successfully giving 5 to 7 minute talks. It's impressive. It's wonderful. So thank you all so much for coming. We're going to be around as we clean up. If you would like to grab a hex sticker, if you haven't already, there are beautiful SLC RUG hex stickers that have our were made in R. If you would like to pick one up on your way out, and if you're interested in giving a talk over the next couple months, we would love to have you. And we will put info about our February's meeting up soon, very soon, so you can get that on your schedule. And so yeah, if you have anything you want to share with us, please do. Thank you all so much for coming.